In this video, I just want to remind you of a few properties of radicals that we've seen before. So, for example, if I have root 5 of 9 times root 5 of 27, what happens is I'm allowed to multiply the insides together as long as these indexes are the same, okay? As long as this, is a 5 and this is a 5, I'm allowed to just multiply the insides together. So when I do that in this case, I get the fifth root of 243. And the fifth root of 243, well, if we have, we might want to do a quick factor tree. And when we do, I can tell this is divisible by 3 because 3 plus 4 is 7 plus 2 is 9. 9 is divisible by 3. And if I add up all the digits in a number and I can divide the result by 3, then the original number is divisible by 3. So I'm going to divide by 3. That gets me 81. Divide by, well, I guess I divide by 9. Get 9, and then this is still not prime, so 3 and 3, and again 3 and 3, and I get 1, 2, 3, 4, 5 threes. So this is essentially the fifth root of this. And what that means is since there's a 5 here and there's 5 threes, I can just take them all out and have 1. So this will be simply 3. So if I do root 5 of 9 times root 5 of 27, the answer I get is 3. And again, you could verify this on your calculator. You could try it. If your calculator does the nth root type operation, you could try it that way. Or you could, do the power of 1 divided by 5. I recommend that you try both. Okay. So this is called the product property, where when you have two radicals multiplied together, you can put the radicands together inside and multiply them. Or one neat thing about this, I love in the definition here, it shows that you could go the other way. If you have something that looks like this, you could break it up into parts, and that's how we simplify radical. So let's say we had something like the fourth root of, 32, something like this. 32 is actually it's actually 2 times 2 times 2 times 2 times 2. And if we take the fourth root of that guy, we can simplify by slicing this guy up into two parts. There is the fourth root of 16, and then there's the fourth root of 2. And so what ends up happening is this guy, these four 2's, they just become 2. Let me go ahead and write that. They become 2. And then this guy is stuck under a radical, which is the fourth root of 2. So two different ways to use the product property. One is, let me go ahead and section this off so you can see its separate notes. Okay, this is where we have a bunch of stuff and we break it up into two separate radicals. This is where we have two separate radicals and we put them together in one and then simplify. Let's also take a quick look at the quotient property. So the quotient property also works in two different directions. You could take a radical that has a fraction under it and break it into a radical over a radical, or you could take a radical over a radical and put them together. What they demonstrate here is that they have radical the fourth root of 162 over the fourth root of 2. They put them together. That gets you the fourth root of 81. 162 divided by 2 is 81. And the fourth root of 81 is simply 3. Yay! Woo! So that's kind of cool. But what if we can also use that to put together, that's what we did right there, we put together 2. We can use it to break up 2. So what if we had something like this? We have like let's do the third root, the cube root of, I don't know, how about 17 over 8. Remember how we hate to have radicals in the denominator? Well, if I break this into two separate radicals, unfortunately I get that nasty situation where I have a radical in the denominator. However, the good news is that I can find the cube root of 8. So I'm stuck with the cube root of 17 on top, but the cube root of 8 is a number. It's 2. Yay! Woohoo! Okay, so there's really good news in these properties of radicals. So we will use these properties of radicals to put radicals together, break them apart, and we'll use that in conjunction with some of the other stuff that we learned. We may convert back and forth between radicals and rational exponents, and we do whatever we got to do to get to the solution that we're looking for.